Okay, so good evening, everyone. Welcome to the fourth week of the TA session for the course Research Methodology in Natural Sciences. So I hope most of you have been visiting frequently for the past TA sessions of the past 3 weeks, and if not so, you could always go back to the discussion forum area, as well as there will be a problem solving assessment section in your course dashboard where you can access all these video clips of the recorded sessions happening every Saturday. So before starting, I would like to ask uh, two questions. Is my presentation visible on the screen? You can either type your answer in the chat box or you can open your mic.
Yes.
Yeah, and I'm audible enough, right? I'm not like my voice is not fading away.
No, no, loud and clear.
Yeah, thank you so much. Yeah. So this TA session is from 3 to 5, as it has been the case for for the past 3 weeks. So we'll be doing the same thing. We'll be going over the recap of what happened in the lectures of week 4, and then followed by a brief 10-minute doubt session, and then we will go towards the assignments, assessment questions for this week, and then we will finish it off with another doubt session. Okay. So, in case if you have any doubts during the session, feel free to ask it during either of the doubt sessions. And throughout the session, I advise everyone else to keep their mics muted and video off so that it doesn't cause any disturbance for the other participants in the call. Yes. So let us move on to the contents of week 4. So yeah, week 4 started off from where the course instructor Dr. Soumitra Banerjee left off. So in week 3, the professor was talking about the history of materialism, how materialism went through a rise and a fall and then a rise again, how materialism and idealism were running parallelly among certain sections of people, and how materialism battled it out with idealism to become the predominant form of scientific communication amongst people who are practicing science. So week 4 starts off with the end of week 3, where the history of different types of materialism is being discussed, and week 4 starts off with how mechanical materialism was propagated. So, can anyone tell me what mechanical materialism is? Like how it was defined? Just a basic definition of mechanical materialism. Okay, if not, okay, I'll tell it. So, mechanical materialism is a materialistic subsection of materialism, a early form of modern form of materialism. Like, it may sound confusing, but it's a very primitive form of modern materialism. So, in mechanical materialism, scientists, philosophers, and thinkers have this notion or a thought process that whatever is happening, yeah, nature materialistic. So whatever is happening in the world, every phenomenon in the world is defined by a law. It's defined by some form of immutable law. So they have this thought process that that whole world acts like a giant machine, out of which every natural phenomena and humans and other living beings alike or non-living beings alike function as small parts of the mission. So, similarly, how parts of a mission can be studied individually, the natural phenomenon which constitutes the functioning of the entire Earth can also be studied using any law. And this applied not only to the constituents of planet Earth, and this also applied to the constituents of the entire universe. Such as similarly to how the Earth consists of several continents and geographical elements, the universe also consists of several heavenly entities such as planets and stars and so on and so forth. So, Similar to how Earth can be studied using this immutable laws, the universe can also be studied using this immutable laws. And Rebal even is also correct. Form is mechanical and based on Newtonian mechanics. It's absolute, like, those are the absolute definitions of how mechanical materialism works. So week 4 starts off with how scientists or philosophers alike tested ideas using mechanical materialistic principles. So they used to take old ideas which were either preached either through idealistic thoughts or materialistic thoughts, and they came up with experience to validate these old ideas. And based on whether it worked using their materialistic approaches in experiments, their ideas were either accepted or rejected. And slowly, mechanical materialism became a forefront, and the philosophical grounding for the modern scientific materialism, not scientific materialism per se, science in general, was based on three pillars. So the first pillar was mechanical materialism, and the second pillar was metaphysics. So metaphysics just says that everything is fixed, everything is things do not change. So the lectures also show you an example of how a tree and a shrub can be are entirely different. So one cannot be either both this and that. It's either this or that. And through metaphysics, there was a metaphysics always followed a either or logic. So changing characters out of our focus, out of our purview. And the third and final pillar of the philosophical grounding of the early forms of modern sciences, formal logic. So formal logic had three major laws, which is a law of identity, law of negation, has, and law of excluded middle. So law of identity almost follows the metaphysics. So an identity is or entity is always defined, and that is that. So a tree is a tree, a car is a car, a cup is a cup, so on and so forth. And law of negation says that one thing cannot be another thing. A tree cannot be a shrub. A tree cannot be a seed or a sapling. A tree can be only a tree. And tree, it's called a tree because it defines it encompasses the properties of that specific tree. And the final law of formal logic is that it's the law of excluded middle. So similar to, so combining, it's almost combining law of identity and law of negation. So law of excluded middle says that there is nothing between A and B. So if we consider a tree and a sapling or a tree and a shrub, there is no such entity which can be considered as both a tree and a shrub. So these three pillars, mechanical materialism and metaphysics and formal logic, constituted the early forms of modern science. And whatever scientific experiments were done, those were followed in this followed using these three pillars. And some of the most important inventions were also discussed in those lectures were cell theory, electromagnetic theory, and combustion engines, and the theory of evolution by Darwin. These famous theories, which went on to make meaningful inventions and give meaningful information to the meaning of life, were discovered, and they were widely began to study. And this was done in the period between 1830 to 1860. But there was a fundamental problem with respect to the philosophical grounding with which these experiments with which these kinds of scientific discoveries were done. And many often people felt that the philosophical grounding is inadequate and needs to be changed. This was because, so we saw in the first lecture that science is always, um, relative. So science is always relative and science is always changing. So what can be the truth in one day cannot be the truth in another. So people will always come up with better experimental plans, and with using those experimental plans, they will always try to come up with more precise or accurate solutions to scientific phenomena. Similar to that, the philosophical grounding also underwent change due to some things. And one of the things, some of the examples were explained through the existence of animals like the platypus. So there were egg-laying animals and there were mammals. And but platypus was an example which was an egg-laying mammal. So there was an exception. There was something between A, egg-laying animals, and B, mammals. So the law of um, uh, here the law of negation can also be not be applied. The law of identity can also be not applied, and the law of the excluded middle, which is neither it can either be this or that. There can also be not be available. And in most of the cases, people found out that while studying a system, so while often studying a system, the mechanical materialistic principles often tell you that, like, they try to give you a picture that the whole is always equal to sum of the parts. Nothing else extra or nothing else less is happening when the parts are put together to form a machine. Like similar to a, so eventually what they say is the, let's just say, a mission, like a world is portrayed as a being a mission. So if we study the parts of a mission, what we're doing is we are also studying the mission itself. So that's what mechanical materialists try to convey. But what happened is people started to realize that when some natural phenomena are studied together as a system, the system starts to exhibit properties of its own. So sooner or later they realize that the whole is sometimes greater than the sum of its parts, which often clashed with the principles of metaphysics as well as the formal logic idea. So people felt that the philosophical grounding needs to be changed, and this uh, thought process or this notion gave to the idea of scientific materialism. So the world started moving from mechanical materialism to a scientific materialism. Scientific materialism says that everything is in a flux, everything is in constant change. So what needs to be studied are not the things, but the change itself. So focus, like the study of scientific phenomena started from changing the focus from study of things to the study of processes. What kind of process helps in this change from change of one thing from A to B? For example, let's just say that a cell, there's a single cell. A single cell is not going to stay as a cell for a while. A single cell is going to give rise to more cells, and more cells, and together they're going to give rise to tissues, organs, organelles, and organs as well, giving rise to a living organism. So rather than studying about the cell, people started studying about what is happening to the cell in while the cell is transitioning into another cell, or when a group of cells are transitioning into a tissue. So what happens during the tissue? So instead of studying as a specific entity, they started studying about the change happening to the entity. And therefore, scientific materialism was also remotely called as a study of matter in change and development. And through scientific materialism, they were able to study not a complex of things, but a complex of processes. And through that, like, sooner or later, they also realized, through mechanical materialism, they realized that total is, the whole is not equal to the sum of parts, rather than the total is sometimes greater than the sum of parts. In very rare cases, the total is less than the sum of parts. And the two pillars on which the scientific materialism rested is that every phenomenon, every scientific phenomenon has two opposite tendencies. And through the lectures, we also come across this notion of frictional force, where if we apply a force, the if we apply a force to a body in rest, the force does not act alone on another object. Rather, a certain frictional force opposes our motion, opposes our force, and keeps it intact, keeps it in a way such that the when we apply a force, else if there is no frictional force, if we apply a small force to object in rest, it's just going to go away. It's not going to like stop at any point of time. So there are always two or multiple opposite tendencies, and we need to study them. And there is no use studying only one tendency in an object. And people started focusing more on quantitative and qualitative changes. Several small scale changes that happen, and large scale changes that um, happen to any scientific entity. By small scale changes, they tell us about any cell division or cell cycle processes. And by qualitative or large scale changes, they address to evolutionary processes, which happen over a large period of time to a large amount of species. And scientific materialism often, so since scientific materialism focus more on change.
Hello, June, we are not able to hear you. Hello.
Can you hear me now?
Yes. Yeah. Last or whatever 30, 40
Yeah.
seconds or 1 minute we lost. There is a
Can you hear me
sound.
now?
Yes.
Yeah, I'm audible right now, right?
Yes.
Okay. How long I was not audible?
30, 40 seconds probably.
Okay. Like I think I was talking about two opposite tendencies. That's when I lost my audio.
Yeah. You are telling like apply force. There will be a reverse force.
Yes. 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 So I think there's a loose connection in my earphones, so I can't audible. Sorry for the technical glitch. So yeah, what I was saying that rather than studying a single tendency in an object, people started to focus on two or multiple opposite tendencies existing in an object, and they also started to study the quantitative and qualitative changes. The by small examples that the lecturer give with respect to the quantitative and qualitative changes are quantitative changes are small cell cycles or cell divisions, and qualitative changes are large evolutionary changes that happen over a large period of time over a for a large population of species. And since scientific materialism always focuses on change of processes, it often negates the previous state of a system. For example, let's just assume that a cell divides into two more cells, like a parent cell divides into daughter cells. So the focus does not remain on the parent cell, rather than the focus shifts to the creation of the new daughter cells. That's how scientific materialism was majorly propagated among scientists and philosophers. And major inventions across the period of 1860 to 1900, where the scientific materialism was introduced to the scientific community, were also discussed, where the major inventions included developmental biology and germ theory by Louis Pasteur, and J.J. Thomson's cathode ray experiment, where he discovered electrons. And one more invention would be the invention of the IC engine. It falls in tandem, like it falls in tandem with the industrial revolution. So the IC engine was a major discovery in this area as well. So people started inventing scientific materialism, but every good thing also requires another not so good thing to be competing with. So some section of people, some section of idealists also started embracing this culture or a scientific thinking called positivism. So positivism is somewhat can be called as a brainchild of um, empiricism. So can someone explain what empiricism is? I mean, empiricism, positivism is one more form of empiricism. So
And coming through experience.
yeah, exactly. So yeah, empiricists often think that whatever knowledge we possess, that comes out of our experience and that comes out of our sensations. And positivism is another form of empiricism, where people think that the existing knowledge or existing scientific evidence, that should only be studied for things which are positive in nature, as in things which are existing in nature. Once again. Yeah. So whatever scientific phenomena, as long as they are existing, as long as they are positive, or as long as they are visible to our eye, as long as there is something to be studied, it can be studied. So that's what positivism propagated. So yeah, and positivism also gave birth to another advanced form of positivism called empiriocriticism in later points, where empiriocriticism is another brainchild of empiricism, is what I would call about it. So it told us that like knowledge is nothing but sensations, our experience. So whatever knowledge we possess, that comes out of our sensation, and sense is the most reliable thing. So it's, you can see that you can draw a lot of parallels to empiricism and empiriocriticism and positivism as well. So all three of them is sort of interconnected in some way, such that there are some minor changes in viewpoints and thought processes. And the main point of empirical criticism, criticists is that people have to stick to what they can observe and measure. So this led to a lot of positives and negative things happening in nature. The positive thing for scientists or materialists is that it it didn't allow idealists to believe or to study something which, like, take into account something which was outside our subconscious mind. For example, idealists majorly thought that matter is not everything. There are some um, other, like, some things which are not part of matter, such as ghosts or heavenly bodies or such, so on and so forth. And for many reasons they started taking those into account as well. So through the viewpoint of empirical criticism, you can't study ghost, you can't take into account of the presence of ghosts, because you can't observe ghosts, you can't measure the activity of ghosts. Therefore it led to the removal of many unfounded beliefs, and this almost buried the thought of idealists. But on the other side, it also led to a lot of negatives, because it didn't allow the materialists, the scientific materialists or the mechanical materialists, to do further studies, to explore much more further about what they cannot see with their naked eye, what they cannot observe or measure with the naked eye. So, uh, this empiricists or positivists, they also did not believe that matter did not exist beyond our consciousness. So, which was the fundamental pillar of materialism. And the lecturer also says that between 1860 and 1900, which was the rise of positivism in among the scientific community, there is a limit in theoretical development due to the rise of positivism. And he also tells on to, like, he also goes on to explain the stories of Boltzmann, who was a renowned physicist and who was trying to um, explain about like once again. So yeah, so he told the most important story of Boltzmann. So Boltzmann was a statistical mechanics, and he, unlike his other predecessors like Maxwell and all those other people, he did not have any other um, area of major study such as other than statistical mechanics. So he made some studies on the existence of atoms and molecules, and he presented it to multiple journals, but those journals or those review committees did not accept his work, and he was persistently chased by these positivists saying that his viewpoint is wrong, and ultimately it led to the discreditation of Boltzmann's work, which with unfortunately ended in um, difficult circumstances and um, other situations for Boltzmann, which we will not be discussing in this TA session. And once again, yeah. But later on, towards the end of the 1900s and 19, especially towards 1904, Albert Einstein started making some studies with respect to atoms and molecules for his PhD thesis. And many of them focused on the study of kinetic theory. So Einstein's kinetic theory is a very popular kinetic theory based on diffusivity of molecules, and he submitted that as a PhD thesis, and it got rejected. But later on, he made some key studies in Brownian motion as well as in photoelectric effect, which gave him the Nobel Prize. So the Brownian motion and photoelectric effect gave immense importance to the existence of atoms and molecules. So this gave people new belief that maybe things which are observable might not be visible to our naked eye, but and we are limited by technology or by infrastructure to not study things which are not visible to our eye. So Einstein's main idea of propagation toward against positivism was that the starting point of anything, starting point of any question should be a logical prediction based on available data or observable data, and this logical prediction can be tested using some experimental testable ramification. And following that, another popular historian called Thomas Kuhn, I don't know if I'm pronouncing it correctly, it's Kuhn. He came up with two major divisions of science. One is the normal science and the revolutionary science. In normal science, scientists majorly focus on small increments to existing knowledge, whereas in revolutionary science, people think out of the box. When certain questions started saturating the community, they sometimes think out of the box to bring a major increment to science. And normal science often is called as a paradigm, whereas revolutionary science is often called as a paradigm shift. And we can also check some of Thomas Kuhn's interviews and testaments in YouTube actually, which deal on paradigm shift. In fact, he is a very well-known, renowned historian for discussing more about the paradigm shift in science. So, in the last part of the lectures of week 4, the lecturer focused on the topic what scientists actually do. So, he starts saying that scientists focus on formulating questions, formulating meaningful questions, not very vague questions, and then they try to answer them using specific rules and regulations. So he started by asking what is the scientific question, how a scientific question is almost framed. So a scientific question should be focused and not vague. So how is everything formed can be a vague question, whereas how is something, a particular entity, so how is a plant formed can be a specific question. It can be studied. So scientific questions should also be always be focused on, not vague, and it should be based on earlier knowledge, not uninformed questions. So whatever question you have, that cannot be baseless. It should have some backing. It should have some early no, backing from earlier knowledge or prior knowledge done by other experimentalists. And it should always, scientific questions should always involve material phenomena, and it should not all it should never like involve feelings. So you shouldn't say start a question saying that I think that this happens, don't you think so, or something like that, because that's your personal feeling. That's what you relatively outweigh things one over the other, so that won't matter when you are asking a scientific question. And types of scientific questions. So scientific questions are always WH kind of questions: when, what, why, how, all those things. And apart from these two kind of questions, the scientific questions are often categorized into closed questions and open questions. So closed questions are those questions which give answers, and those answers will not lead to further questions. So if you are going to calculate any constant for a parameter, that that constant is just found out, and you don't need to answer any other question using that answer. On the other hand, questions which give answers which lead to further questions, which lead to, it's a chain of questions and answers, those are called as open questions. And in the last part of the lecture, the instructor also um, lists out the rules to answer a question. So there are certain rules how, when a question is posed to you, there are certain questions how to answer it. So the first step is to propose and test a hypothesis, and the next step is to propose and test postulates. Postulates, like almost they are almost they can be compared with hypothesis, but only difference between postulate is this: a postulate is a scientific guess regarding any natural prospect or a law of nature. And following that, you will be measuring something using measuring some constant or a parameter using a machine or using an experimental setup, and then you will be establishing a relationship, kind of a linear relationship or a non-linear relationship between a dependent and an independent variable. In most cases, and not in most cases, in some cases, there may be only one independent dependent variable or independent variable. In some other cases, there can be multiple variables involved in the question, and combining all the answers from certain relationships between variables, you combine them all together and develop a mathematical model of a particular um, process. It can be either biological or outside biological. It can be physical or a chemical, but using all the functional relationships you obtain from studying all the processes, you obtain a mathematical model, and then you try to use that model to seek something new. Either seek a new answer to some question or use the same model to further explore the same system. So that's all for the recap session of week 4. So I'll open the room for doubt sessions till 10 minutes, and then we can discuss the answers for week 4 assignments. You can either type your questions in the chat box, or you can raise your hand and then talk through the mic if you have any questions. Okay then. So I think no one has any questions for now. I mean, it's kind of understandable since um, it's compared to, like, similar to week 3, week 4 is also a very factual week. So almost all of them involve a major chunk of history as well as some very factual data. So there is no, like, compared to week 2, I don't think there is any logical reasoning you need to apply to many stuff. So I am hoping that there are no major questions in this week compared to the week 1 or week 2 questions. So we'll directly go to the assignment. Like, I think this will be a shorter TA session compared to the other weeks as well. So we'll directly jump to the TA session, question and answer session. And once again, so this is just a major, like, answers are just compiled by me. Like, this is not the official key. So let's go into that. So first question is, the characteristic features of a metaphysical outlook are, there are 4 options, and it's a multiple select questions. So metaphysics, we saw about that. So it's a very, it's a thought process which says that everything is fixed and nothing is changing. Rebaliban and Mayuri are saying A1. So that was the MSQ. So you need multiple options. Saurabh Kumar is saying 1 and 3. 3 is belief that everything has fixed properties, and the tendency of viewing things in isolation from their condition of existence. Mm, yes, but can you elaborate on that? Can you try to elaborate on that? Like, of course, it's correct, but it's a bit. Um, third question is the third option is a very bit stretched out version of option 1 as well. Option 1 is a just direct out definition of metaphysics. So metaphysics says that the belief that everything is fixed properties, because, like, everything is fixed. That's what physicists do. But apart from that, the tendency of viewing things in isolation from their condition of existence. Um, that is because metaphysicists don't study about change. They study about only the object in question. So since they don't believe in change, they are just going to believe that the object is kind of isolate or um, solitude in nature. So they are not going to study about anything that is going to happen to the object, rather than they are going to study the object itself. So the correct options would be 1 and 3. The belief that everything has fixed properties, and the tendency of viewing things in isolation from their condition of existence. Does anyone have any doubt with this? We can move on to the next question then. Okay, then we'll move on to the next question if there are no doubts. Like as usual, if you get any doubts in between, you are always free to like feel free to ask. Like after the question answer session, where we'll have another doubt session. So almost the same question, but this time it deals with mechanical materialism. So the characteristic features of mechanical materialism are, this is also a MSQ. So I think this is also a very factual question. So uh, viewing the world as law governed. So everything follows a immutable law. Yeah, Mayuri, you are correct. It's option three, but it's an MSQ. So I think this is one fact you guys should keep in mind. So MSQ always requires one, like more than one answer. Yeah, like it can be either two or three or all, even all the options, but it'll definitely not be only one answer. Saurav Kumar 2 and 3, yeah, it's given there, yeah. So two things. So mechanical materialists always think that world is giant machine. Everything in this part can be like every part in the mission contributes to the whole mission as well, and everything follows the immutable law. So it's law governed, requiring no divine attention. Yeah. So this is also a very pretty straightforward question. So if there are no doubts, we can move on to the next question. Okay, a pretty factual question once again. Positivism asserted that there are four options, and it is once again a multiple select question, and you can already see like what are the two options. So it's universe is infinite. Yeah, Saurabh Kumar 214. So Vijay, so you are saying two and three. So, but positivism said that everything you can only measure, you can only experiment on what you can. Positivists said that you can experiment on only what you can observe and measure. So the main idea was that they negated the existence of atoms and molecules because you can't observe them, and that is the main reason why Boltzmann got so much slack. So yes, so the answers are two and three. So both of them are pretty much straightforward answers to positivists. So they said that they can only based on only what you can observe and measure. So atoms and molecules are automatically out of the picture if we choose two. And source of all knowledge is the sensations we receive from our five sense organs. Because positivism is a brainchild of empiricism and empiricism. All three of them are linked together. So two and four will be the correct answers. I hope it's clear to everyone else as well. Like when you talk about positivism, like this is for everyone in the call as well. Like when you talk about positivism and the characteristics of positivism, they almost always think that atoms and molecules still do not exist. Like because we don't have like because at that time they didn't have any um, experimental infrastructure or the capability to observe them. Later on, some positivists, after the invention of certain microscopies and certain crystallographic methods, they came to a conclusion that okay, maybe everything is made of atoms and molecules, and they also shifted their viewpoint to scientific materialism. Yes, but this is the original, like these options two and four are the original pillars of positivism. Yes. So, fourth question, the characteristic features of scientific materialism are almost similar to one and two question, but this time it deals with scientific materialism, and this is a multiple select question. So more than one option is correct. So Saurabh Kumar 2 and 3, mm, understanding that everything in the process of change and evolution, very correct because everything is in a flux, and the realization that processes are more fundamentals than things. Yes, that is also so. Uh, Scientific materialists focused on two things. So they believed that everything is changing, and it's more important to study the change rather than the process itself. So these two are the belief that matter does not exist independent of our consciousness. That is almost not the viewpoint of scientific materialism. Um, and believe that biological organisms are a product of intelligent design, it's totally different. It's from the week two's reverend lectures where he intelligent design must have a owner as well. Yes. And week 5, sorry, question number 5, Einstein believed in multiple choice questions, and this is pretty much straightforward. It's scientific materialism. Yes. Yes. So he was battling. So at the time, positive at the time of Einstein, positivism was at a very much higher position. But Einstein always believed in the existence of atoms and molecules, which led to his scientific materialistic thinking of experiments. Question 6, pretty much straightforward. Boltzmann's work was rejected by scientists of the time because it's a multiple choice question and is based his work on the assumption that atoms and molecules exist. So he proposed a theory, he proposed theories from electromagnetism and statistical mechanics, which said that everything is based upon atoms and molecules. Atoms and molecules are the fundamental particles of matter, but positivists rejected his idea, saying that you can't take into atoms and molecules because they don't exist, and they don't exist because you can't see them or observe them or measure them. Proved to be wrong by contemporary positivists. Um, yes, actually, in this question, I also think that question number 1 could be a more fitting answer as well because um, but the reason I didn't take this into consideration is because that's the question itself. Like Boseman work was rejected by scientists of all the time. Like I just tried reading the question and this answer, and it seemed repetitive. But I would say that an answer is 1 and 3 as well. His theory contradicted experimental results is not a obvious answer, and 2 is also not an obvious answer. So it's either 1 and 3 or it's just 3. So we will discuss about this in the next week's lectures as well. Like I'm not sure of what the answer would be. So if anyone doesn't have any doubts, I'll move on to the next question. Pretty much straightforward question once again. A closed question is um, if you find out the answer to a question, it does not lead to further questions. Yes. Oh yeah, all of them, all of you are correct. So, and then next question. Thomas Kuhn proposed that it's an MSQ. Okay, so Thomas Kuhn, yeah, 1 and 4. Yeah, I mean you are correct. That it's 1 and 4. Science should not. Yeah, Mayuri is saying 1 and Roshni is saying 4, but these are also like half answers. So Thomas Kuhn said that there is a part of a normal science, that is an evolutionary science, and there is the revolutionary science. So evolutionary science makes small increments, like which answer your day-to-day questions, and when the science and when normal science saturates, scientists start to think outside of the box. Yeah, yeah, I am trying to explain the question, Mayuri. So Thomas Kuhn said that there is a normal science and a um, revolutionary science. So normal science's other name is just evolutionary science. So he said that evolutionary science makes smaller increments to science. Those kind of scientists answer day-to-day questions, And when these kind of questions start saturating, then the other group of scientists called revolutionary scientists, they start to so once again, sorry, I have a bad cough. So yeah, so these kind of revolutionary scientists, what they do is when science starts saturating, they try to think outside of the box and they try to bring a very large increment to the existing scientific knowledge. So these are the two different categories in science. And yeah, the development of science is always marked by paradigm shifts. So paradigm shift is a major characteristic of the revolutionary science part. So the small increments that we make to in normal science or evolutionary science, that forms the paradigm of that particular time period. And once the paradigm saturates to a certain level, it is marked by a paradigm shift. It's where the set of scientific studies focuses on to a whole new advanced level of science or to a different area in science. So I hope it's clear to everyone. I hope the difference is clear between paradigm and paradigm shift. Yes, okay. I'll just wait for a minute in this question to see if anyone else has any clarifications or doubts as well. Then we can move on to the last two questions. Okay, then. So, yeah. So, which theory in science, question number nine, which theory in science resulted in the development of mechanical materialism? Yeah, so it's Newtonian mechanics. So, Darwin's theory of evolution, theory of relativity, Galilean transformation came way before mechanical materialism, and Darwin's theory and theory of relativity came after um, the invention of mechanical material. In fact, they almost came in the advent of scientific materialism. So, Newtonian mechanics is the correct option. And last question, regarding the existence of molecules, the position of positivism was. So we already discussed about the stance of positivism. So Kumar 4, since they are not observable, they don't exist. Yes. So we already discussed about the um, several aspects of positivism, that they are limited to only our senses and experiences. So whatever is not observable or measurable, they do not exist. So molecules follow the same path. They are not observable using ordinary infrastructure, like or the infrastructure of their time during the 1900s. Therefore, we cannot observe them, and therefore they do not exist. They exist independent of our consciousness. That's wholly completely different. That's related to matter. They exist in our consciousness, also related to matter. They can be seen with microscopes. Nope, not the view of positivism. And like microscopes weren't that popular during that time. So yeah. So these are the 10 questions for this week. And once again, like there are some doubts as well. So we'll, for the people who joined late, I'll just briefly go over the questions and answer one more time. So the characteristic features of a metaphysical outlook are option number one, the belief that everything has fixed properties, and option three, the tendency of viewing things in isolation from their condition of existence. And question number two, the characteristic features of mechanical materialism are option number two, viewing the world as law governed, requiring no divine intervention, and option number three, viewing the world as a gigantic mission. Uh, Third question, positivism asserted that option number two, the science should be based only on what we can observe and measure. Option number four, the source of all knowledge is the sensations we receive through our five sense organs. Question number four, the characteristic features of scientific materialism are option number two, understanding that everything is in the process of change and evolution. And option number three, the realization that processes are more fundamental than things. Question number five, Einstein believed in scientific materialism. Question number 6, Boltzmann's work was rejected by scientists of the time because he based his work on the assumption that atoms and molecules exist. And question number 7, a closed question is, if you find out the answer to the question, it does not lead to further questions. Option number 2. And question number 8, Thomas Kuhn proposed that, um, I think, yeah, yeah. So question number 6, it's still pretty skeptical about it because option number 1 and 3 can also be correct. But let's take it next week. So Thomas Kuhn proposed that there are evolutionary and revolutionary departments in science, and option number 4, the development of science is marked by paradigm shifts. And question number 9, which theory in science resulted in the development of mechanical materialism? Option 3, Newtonian mechanics. And option number 10, regarding the existence of molecules, the position of positivism was, since they are not observable, they do not exist. Yes, so these are all the 10 questions. So I'll open the room. Like, I think this will be a very, very short TA session compared to the previous 3 weeks. Because, yeah, so I'll just open the session for another 10-15 minutes. And if not, we will close the session for this. Question number 6 is only. Oh, okay, okay, yeah, okay. I totally forgot that. Oh, thank you so much for pointing that out. Yeah, so yeah, now it makes more sense. So it's an MCQ, so only option 3 is only like the most sensible option of. One second. Yeah. So yeah. So it's an MCQ. So only one option can be this thing. So one option can be correct. So option one is a more repetitive form of the question itself. So I don't think it can be correct. Yes. So Mayuri is saying, can you please explain again paradigm? Okay. So paradigm, I think it's okay. Okay, so paradigm. Wait, I have to think how to start explaining about this. So let's just take a typical definition of what a paradigm means. Paradigm can be uh, paradigm can be explained as a sort of a state or a pattern or something like, or a typical what to say, a niche sort of thing. If you know like what these terms mean, wait, I'll just type in the box. So paradigm literally can mean these words in different contexts. If anyone else has a more uh, correct or precise meaning, they can also shoot it up in the chat box or in the mic. So let's just take paradigm as a state. Yeah, generational shift. Mayuresh. Yeah. So generational shift, I think it also specifies to a state of, in this case, it refers to a state of science in that in the context. So what kind of science are they focusing towards? What kind of discipline of science? So in week 3, we were seeing that physicists and chemists were doing their experiments much more faster, and there were very fewer biologists in question, or there were very few biologists doing their experiment, because major questions in biology were almost covered with idealists. The questions to major questions to biological phenomena were often answered by idealists, though for a major period of time there wasn't any technical advancement in the field of biology. So I would say that for a certain period of time, the paradigm was focused more on physics and chemistry, and then sooner or later towards, like, I think for the past 40 50 years, I would say the paradigm has shifted more towards biology, because people have started answering those questions which were earlierly occupied by idealism. So we could say that compared in the last century, there has been a paradigm shift in biology, and this paradigm shift is often caused by revolutionary scientists and revolutionary developments, where people often get saturated by questions in physics and chemistry. So they try to think outside of the box, and they try to answer the questions in different disciplines such as biology, which will often help them track back to their original principles and carry forward their research in that area. I hope it is clear. Okay, Shauruk Kumar is saying a paradigm refers to a framework or a model that shapes how something is perceived or understood. Scientific paradigm example is Newtonian physics and quantum mechanics. Exactly. Yeah. So yeah, precisely. So there were some questions which weren't uh, which we can't answer using classical mechanics. So questions in classical mechanics started saturated. So people started shifting towards more towards quantum mechanics and started explaining state vectors, and they started solving problems through quantum mechanical phenomena. And I think the invention of, like, the fundamental um, property of quantum mechanics is the creation of a state vector. I think if people who are working more in quantum mechanics can explain, it will be better. But according to me, like, the creation of the state vector is the most fundamental part in quantum mechanics, and that helped physicists solve a lot of problems in the area of quantum mechanics, which could not be answered through classical mechanics. Mayuresh Shethe, yeah, yeah, sure, sure, sure. I can just go through. So
Arjun, really sorry for this.
yeah, yeah, yeah. So we can go through this, but I'll just make a quick
Yeah, you need
announcement.
not to explain. Yeah, that I'll go through once again once you upload the video.
Yeah, yeah. So I'll just make a quick
Yeah.
announcement before we can go through all the things, because I think, like, we have covered the TA session once. So actually, what happens is that normally my TA session happens every Saturday from 3 p.m. to 5 p.m. But that won't be the case for next week, because next week, like, I'm from IISc, I'm a PhD student in the Indian Institute of Science. So IISc is having an open day next week on the 24th of February, and it's a all day activity. So if any of you are from any institute in Bangalore, feel free to just come up to IISc, and its entry is almost free. So one important thing is that the TA session won't be happening, because I will also be busy in this open day. So instead of that, my next TA session will be happening on 25th of February from 3 p.m. to 5 p.m. It will be on a Sunday, 25th of February. You will also be getting a formal announcement from the NPTEL team about the next TA session alone. So, like, I'm very sorry if it's being out of schedule, and I'm announcing it only a week before. But I needed a, like, I was expecting for a rescheduling slot from NPTEL team themselves. So that's why there is this delay in announcement, and you'll be getting an announcement from NPTEL team as well. Yes.
Arjun, out of context, but just one coincidence. That is, I was in ISC between 14 and 16, 2014 and 16, and I was organizer for mechanical engineering both
Oh, okay, okay.
the years. Open day. Yeah, 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 yeah.
Okay, okay, okay.
It's one of the
Good.
best event and best days of the ISC.
Okay, okay. Nice.
Yeah.
Nice to hear that. So yeah, that's about that. So it'll just be a the next TA session will be on Sunday instead of Saturday. So with that, I'll just go through the question and answers once more. So, question number one, characteristic features of a metaphysical outlook are option, the belief that everything has fixed properties, and the tendency of viewing things in isolation from their condition of existence. And question number two, the characteristic features of mechanical materialism are viewing the world as law governed, requiring no divine intervention, and viewing the world as a gigantic machine. Question number three, positivism asserted that science should be based only on what we can observe and measure, and the source of all knowledge is the sensations that we receive through our five sense organs. The characteristic features of scientific materialism are the understanding that everything is in the process of change and evolution, and the option number three, the realization that processes are more fundamental than things. Question number five, Einstein believed in scientific materialism. Question number six, Boltzmann's work was rejected by scientists of the time because he based his work on the assumption that atoms and molecules exist. Question number seven, a closed question is,
Just sorry for the disturbance.
yeah,
Question number six. No, I also thought that why not to go for option number one, because it was proved wrong by that time's
yeah.
positivists that
So primarily, I would assume that option three is correct because that was the reason that his work was rejected. So
okay.
he performed experiments in EM theory following Maxwell's work, and his work majorly involved the assumption that atoms and molecules exist, and therefore this happened, and that and majorly positivists were on the committee for major journals, and they rejected his work because they said that, see, this don't exist. We believe that atoms and molecules don't exist because we can't observe them.
Okay.
Yes.
Okay, clear.
If it is an MSQ answer, then I would go for one and three.
Yeah.
Yeah.
Right.
Then question number seven, a closed question is, if you find out the answer to the question, it does not lead to further questions. So gravitational constant and all those stuff. Thomas Kuhn, question number eight, Thomas Kuhn proposed that there are evolutionary and revolutionary developments in science, and the development of science is marked by paradigm shifts. And question number nine, which theory in science resulted in the development of mechanical materialism? Answer is Newtonian mechanics. And last question, regarding the existence of molecules, the position of positivism was, since they are not observable, they do not exist. Yeah. So that's about it for the question and answer session as well. So yeah, no thanks. So yeah, I'll leave the room open for another 10 minutes, and if you have any doubts, you can shoot it up. Else we can end the session, like end the very short TA session compared to the other 3 weeks for today. Yeah. Yeah. Thank you. Thank you. Okay then. So I don't think anyone has any questions as of now. So I'll end the session right here. So yeah. So thank you all for coming. And yeah, as usual, so if you have any other doubts, so this this lecture is recorded like while we are speaking, so it will be uploaded to uh, a YouTube channel which you can access through the NPTEL website through your course dashboard. And if you have any other doubts, you can mail me in my mail given in the introduction slide, and you can also shoot up the doubts in the discussion forum, which you can access through the NPTEL course dashboard once again, and we will be ready to answer. And there will also be another TA session on Tuesday by another TA from 7 p.m. to 9 p.m. Yes. So if there are no questions, I'll see you all next week, 25th February from 3 p.m. to 5 p.m. Yes. We'll be discussing week 5 lectures then. Thank you then.